we'd like to do is quickly run with the slides so that we have enough time for the Q&A and the debate. Reggie Sahab, how much time do we have? We have until what, 12? It's about 11:40 now. We start 12:15.
Smile. Presentation mode. Presentation mode. Load it up. Sorry. See? Okay. Good morning once again to everybody. Thanks a lot for coming over here. My name is Jimmy Chalakkal. I represent the company called Analog Devices. We are into semiconductors, serving the markets like energy metering, industrial, instrumentation, healthcare, and military and aerospace business in India. I specifically provide the technical support to Indian customers who manufacture these items in India. And we have been closely associated with the metering manufacturers, so we clearly know what exactly is the challenges they face on a day-to-day life when they execute these kind of orders and install these kind of meters. So in the brief presentation, what I have, precisely 5 or 6 slides, I basically want to talk about the RF challenges, what we face when we install an RF-based system onto the smart meter, the basic approaches to solve that problem, and the solutions. So there are challenges for RF communications and metering. What are the best approaches? In terms of solutions, we basically talk about the radio coverage. Coverage is more important here. Co-location and penetration. So what do you mean by co-location? Co-location means we have multiple meters basically situated at the same premises, for example in an apartment. So what are the challenges involved when you deploy meters in that form? Penetration. When you have meters installed in your basement, for example, how do you extract the data out from there, right? What type of modulation we have to use? Is it frequency hopping, FSK? And that's what we are actually trying to promote here. And what are the conclusions and recommendations? So let's look at the challenges here. First is radio coverage. The limitations are in terms of geography. There can be situations where a house for which you are trying to install a smart meter is located close to a telecom tower. The interference, the RF interference, what you can expect by installing installing a smart meter in that vicinity will be very high. So how do you mitigate that issue? We cannot ask the household guy to actually move from the tower so that we can install smart meter. That is not possible, right? So how do you mitigate that issue? The cost to cover the last 2%. In most part of the world where we have interacted with customers and the utility companies, what they told us, even today, even yesterday also, we had the same discussion. The last 2 to 5%, how do we effectively cover that? And that represents the bulk of the AT&C losses what we face in India. We talked about collocation and penetration, which I'll go through it later. Interference also I just spoke about. There can be multiple types of interference, depending upon the choice of frequency what you're going to select as far as RF communication is concerned. Limited channel bandwidth. Channel bandwidth also plays a role in terms of providing reliable communication. If you want the communication to be reliable, you need to have higher channel bandwidth. And the last one is the higher performance radios, which needs to have good interference performance, strong immunity performance, the sensitivity, and you also need to have efficient antennas and the power amplifiers. A combination of these things can actually make your smart meter much more reliable than what it is today. So if you see the radio coverage here, there is a fundamental frequency, the principle. Reducing the frequency range basically increases the range. And what you can see over in that particular slide, is about link budget. We talk about link budget by taking into consideration the gains and the losses. When a signal is transmitted from the transmitter, it passes through a medium and it's been received by the receiver, right? And if you do a link budget, and if you keep an apple-to-apple comparison, what we can see here is that the sub-gigahertz performance is almost 2.8 times than that of a 2.4G performance. And that's the theory, and that's what is practically we can achieve also. And the last one is the frequency hopping techniques, which I explained to you earlier in short, which allows a short burst of data to be transmitted over multiple channels, multiple narrowband frequency channels. So as you can see in the figure there is a strong interference which is coming from the mobile. Okay, for example, it's a mobile. You can see that. And it's been passed away because we actually try to communicate over a narrowband frequency channel, right? In a direct spectrum, the same noise is actually spread across different channels. So we're not trying to propagate the idea of using DSS for these kind of technologies. Rather, we will go with FHSS. And what we have found in the previous slide is what you're seeing across the globe. What kind of implementation is actually happening across the globe. In US and Europe, in China, in Japan, you look at any place, world over, the utility companies and the customers have actually adopted sub-gigahertz as a choice of RF frequency for smart meter. And this slide basically explains that one in very much in detail. Now, coming to India, we also need to be very clear to which frequency band we need to adhere to, whether there exists a need for us to make sure that two bands coexist so that the meter deployments can actually happen in both the bands. The next challenge is the co-location building penetration, which I explained to you earlier, but these are something which is at the RF IC level, which I don't need to go through in detail. If you want, you can actually go through a slide later on. But when you select an IC, what we need to, especially because there are no metering manufacturers excepting for Genus, I would like to skip this slide. Basically, it talks about the RF ICs in detail. The modulation scheme, what we recommend is a frequency hopping FSK. It has got a lot of advantages. It's quite simple. It's lower cost in terms of implementation. It has sufficient performance and range. And all the more, it's the easiest PHY to standard to test for interoperability. The QPSK or the OFDM, even as far as when it comes to .4G standard, it becomes much more complex to actually test for interoperability. And this is my conclusion here to sum up. Sub-gigahertz FSK is the right solution as far as our experience is concerned after working with many of the utilities across the globe. It addressed the coverage challenge by adopting frequency hopping techniques. It addressed the building penetration challenge because it can give you more power. It addressed the co-location challenge because it takes care of both interference as well as hopping techniques. It addressed the lower cost challenge. It also addressed the interoperability challenge via 802.15.4G. But if you want to reliably do all those communication standards, what we need is a higher bandwidth. The existing 2 megahertz bandwidth, it's actually not sufficient for us to reliably implement this communication technology. So it's up to ISGF to take it up with the right forum and try to increase the band, in the sub-gigahertz if you want to actually, deploy meters in the sub-gigahertz band. With this, I end my presentation. Thank you very much.